start on the final topic to address for this class before the second exam. Let's remember that the second exam is coming up. Remind myself when the second exam is. Okay, so we have about a week and a half until the next exam. Have a look. So I've had a number of people ask me after the first exam, what is the best way to prepare for these exams? So the best way to prepare for these exams is to first look at the existing exams that are out there. I will give you the answers to these exams as we approach the next exam, but look at the exams on cse2.lehigh.edu to familiarize yourself with what the second exam is like. It's very different from the first exam. The first exam is different from all the other exams in the class in that you don't generally write a whole program for each question, but exam 2 is much more focused on writing consistent code, and you just see a lot more large boxes. So there will be a lot of questions of this structure. Write code that will reproduce the pattern. So the best way to prepare for an exam is looking at these exams that I have available for you. And also, the second best way to prepare is to look at the book. So a lot of the people that I've talked to in this class who did really well, they succeeded by first doing the exams and then second do the questions in the book that are example questions. And they're sort of very different from the kinds of questions that I ask, but they get you thinking about the code in different ways. So that's a really important variation. Okay, so the second major topic for the second exam is methods. Methods are a very flexible kind of code container that doesn't really have any other analogs in the syntaxes that we learn in this class. So we learn about loops and if statements and switch statements, and they have a lot of similarities. Like while loops and if statements have a lot of close similarities. But methods are totally different. Methods allow you to create a separate container from your main method and call that code whenever you want. And it gives you a very flexible, very universal way of reusing code. So whereas the if statement and the while loops and the for loops all control very precisely how you reuse code, and if you want to reuse it in a more flexible way, you don't have that control. Methods give you code that is available at your fingertips, however you want to use it. That makes them very powerful and very flexible. And the design of your methods, even more so than your if statements and your loops, dictates the structure of your code and also allows you to create designs that are both efficient, easy to read, and effective. So we've already seen examples of methods, and you guys are already using these examples. But I haven't made an effort to formalize their usage because it's been a topic that I've been sort of pushing off until now. These examples that you use of methods, like when you write system.out.println, we have this word that has parentheses after it. I've called that a method or a function. These are methods, and you've already been using them, but now you're going to learn how to write your own. So before and throughout the class, we use these methods that Java provides to us because they're shortcuts for doing things. And what you're going to learn to do with methods is learn to create your own code that you can use in a shortcut way, the same way that you call on this code here, like math.random and system.out.println. Okay, so how do we define our own method? You may recall that in the first or second lecture of this class, we talked about how a lot of the code that you write will be inside the main method. This is the first time that we will step outside the main method and write something else inside the class, but outside the main method. So if I have this class structured in this way, public class demo, and I have my standard main method here, public static void main string args, my new method, my new custom method here, will be outside the curly braces of the main method, but inside the curly braces of the demo. Okay, so what does a method do? A method holds code that you want to run, and that code exists as a kind of shortcut anytime you call that method. So let's review some of the terminology here. So methods are frequently called functions, and functions are frequently called methods. And the reason why that's the case is history. So in older programming languages like Fortran and C, we refer to methods as functions, and in newer programming languages, we refer to them as methods. So you'll hear a lot of old-timers call methods functions and functions methods. That's because everybody's referring to the same thing. Another point of terminology is the word call. When we run a method or reference a method, the correct terminology to use is to call a method. We call a method or call a function, or we invoke a method or a function in order to get the code that's running in that method. So a method is like a miniature program. And when we talked about programs at the beginning of this class, remember that the definition of a program was that it takes specific inputs and it generates specific outputs. And a method is exactly the same way. So a method takes predefined inputs and it generates predefined outputs. It's like a little program that you run inside your program. And unsurprisingly, it has this kind of structure where your main method, which until now was your entire program, calls this other program, this custom method, in order to get the code that will run inside that method. Okay, so when we want to use methods, we have to first declare the method, and then we have to call the method. So when we declare a method, we always have to have a certain structure. We need to have this structure here. It has to exist outside the main method and inside the class. In CSE2, we will write only public static methods. So these are modifiers to what a method is. And just, it's not critical to know this, but I want you to have heard it once at least, that the reason why we're writing these public static methods is just because this is the most simple way to design a method. There are ways to control methods for whether or not they are accessible to code outside the class. And in CSE 17, you will frequently deal with code that is running in multiple classes. And sometimes it's convenient to make some methods invisible outside the class. Other times it's important to have methods that exist only once an instance of the class has been created. Both of these terms, public and static, control the situation in which a method can be run. In this class, we don't care about that. So we're always just going to use this default, public static. So we can treat that as a kind of incantation for your methods. That you speak the incantation and then you define the method and you've got your method declared. But so all of your methods will be public static. And then there's this word here, void, and I'm going to explain that in a second. And then there's the name of the method. And inside here, there are the inputs. And we'll talk about how all that is. But this is how you declare a method. Okay. So I just explained this, even though in earlier classes I've said that don't worry about this. But that void was, in the earlier example, is an int here. And what this word is the output type. So remember how I said that methods always have a specific input and a specific output. This is defining the specific output of a method. A method always generates an output of a specific type. It cannot generate outputs of different types. So that void is a very special word, because a void is saying that this method doesn't generate output. So the kinds of outputs that you can have from a method are basically the types that you've learned about so far. Ints, doubles, floats, strings, booleans, chars, etc., etc. But there's one additional type that we're learning about here, the void type. And the void type is simply a placeholder that says there isn't a type because this method doesn't generate output. Okay. So you need to have a name for your methods. When you write your Java code and you don't have methods, you only have a main method. That main method is called main because that's a reserved word in Java and many programming languages, which says, this is the method that we start at, this is where execution happens. So that's why we have to have a word called main. Now, when we have a secondary method, a method that the user has written, the programmer has written, then it has to have a specific name, and it cannot be main. But it can be many other things. So in this case, I've called the method rect area. When you call the method, you must, of course, call the method with identical capitalization. You can't have variations like that. And then finally, the things inside the parentheses refer to the inputs for the method. A method can have multiple inputs. You will occasionally see methods with a very, very large number of inputs, but it's stylistically a good thing to have as few inputs as is absolutely necessary. Minimalism is a great thing for methods. And here I've defined the inputs and their input types with essentially declarations that are comma delimited. So here I have a width. I'm telling you that it's going to be an integer. I also have a height, and I'm telling you that it's going to be an integer. And to declare all the inputs, I'm basically going to say in width, in height, and if I had anything else, it might be like double length or something like that. And then after the curly braces, the code goes inside the curly braces. Okay, so after we've declared a method, we can call that method inside the main method or inside another method by referring to that method name, in this case, rect area. And I pass in the data that I want to provide for rect area's input. So rect area takes an integer width and an integer height. That means that I need to provide it an integer and an integer inside the parentheses here. So in this case, it takes page width and page height. And note that I've scrupulously made these variables different names, because it's critical to note that I can put in anything that evaluates to an integer before the comma, and a second anything that also evaluates to an integer after the comma. All that rect area is looking for is an integer in both of these positions. So that means that I could have some crazy arithmetic calculation here where maybe I'm casting things, maybe I'm converting things, I'm adding things together or multiplying them. But as long as that expression evaluates to an integer, that will compile. If it doesn't evaluate to an integer or it can't be implicitly casted to an integer, then it will give you a compiler error saying that the method requires this type, and it can't find a method that accepts the type that you're giving it. So you must always provide variables or literals that are the types that are requested in the method's declaration, or variables or literals that implicitly cast to the types expected in the method declaration. Okay, so how do we call a method? When we're running this method, we're going to expect this to run and generate an output. And in this case, we're going to assign the output of this method into the variable area. To think about exactly how this method runs, once we provide the input, page width and page height, that input is going to go into the rect area code. That code is going to run and generate its output. And the output is essentially going to replace what I have here for the method call. The method call is going to basically convert down into whatever that output is. So you can think of this, this little expression here, rect area, as being an expression that is equivalent to an integer. Because I've defined rect area as returning an integer. After rect area finishes running, this is going to be an integer. So when I attempt to assign the output of rect area as an integer into this variable area, it's okay with assigning that because rect area generates an integer as output. Now, if rect area generated a double as output, this would be a compiler error because I couldn't, this would be a compiler warning, excuse me, because this would be a compiler error because I would be attempting to store a double into an integer variable. I'd have to have an explicit cast in order to store that output if it was a double into this integer.
What is the key kernel?
Sorry?
The variable names provided in the helping out. So key.
Yeah. So excuse me. Let me use the previous slide to explain that. So the question is, what is the significance of these variables in the call being different from these variables in the declaration? So in the declaration, we call these the method variables because they're the input variables that are provided to the method. So it's simple to call them the method variables. But the inputs provided to the method can be anything, including other variables.
But not it has to be two variables if it's 2 or 4.
That's right. It has to be two variables, and they have to be the same types. But they do not have to have the same name. And so a common rookie mistake is to expect that you have to have two integers here, where one is defined as width and one is defined as height, exactly spelled this way, capitalized this way, and plugged in here in order to make it work. That will work, but in fact that's kind of a bad stylistic way to approach it because that makes it a little bit confusing between what's here and what's being used here. And it also might be really inconvenient if you want to use these variables for something else. So what's happening here is simply we're passing these values in. It's getting the values out of these variables and providing the integers inside those variables into rect area for the method.
Could you put, like, instead of page width, just an integer there?
Yes, you could. So instead of putting a variable here, you could have a literal integer, like the number 8 or the number 500. Yeah?
Does the method rect area have to appear before the main method?
Good question. So the question is, does the method rect area have to appear before the main method inside the class? And the answer is no. So as far as the class is concerned, the methods exist in any order, and it will find the method that it needs, or it will find the main method based on the name of the method. So stylistically, people typically put the main method either at the bottom of the class or at the top of the class. It's at the top of the class frequently because, well, we think of code as running from the top of a list of instructions. And so having the main method at the top is sort of synonymous with that. Frequently, it's also at the bottom of the main bottom of the class because that's another easy way to find it. So you see it both ways, and I'm of no opinion of which way it should be. Just not in between other methods. Okay, so let's now put content inside our class, our method. So our method is going to return a particular value, and in this case, it's going to calculate the rectangular area of some sheet of paper or something. So we're going to use this special word return to return the results of rect area. So return is this new special word that we're learning, which is saying exit this method with this output. So in this case, the output is going to be width times height, which is going to be my rectangular area. And this has to evaluate to the same type that's defined in the method declaration. So the method declaration states that rect area returns an integer. So when we have something after the return statement, whatever this expression is must evaluate to an integer, otherwise it won't compile. Because that's like saying that you declared your method to return an integer, but for some reason you wrote the code to return something else. That's not going to be okay. Now, it could, of course, implicitly cast to an integer. That would be Java sort of making everything clear. But if it cannot be implicitly cast, then there would be a compiler.
And do you have to declare the integer in the parentheses? Or
The integer in the
for
parentheses.
public and rect area, do you have to write intent? Or is there any way you could declare with or anything before that?
Okay, so the question is about the method variables. Method variables must be independently declared. So if I have 2 or 3 integers, I can't say int width, comma, height, comma, length, comma, number. I have to say int width, comma, int height, comma, int length, comma. And the reason why that is that the method determines what the inputs are based on the order in which you write them in the method call. So when I call a method with something, comma, something, comma, something, then the first thing always has to be the first method variable. The second thing always has to be the second method variable, and so on and so on. So that's why there's no shortenings to the definition, the declaration of the method variables. They have to be declared exactly type variable name, comma, type variable name, comma, type variable name, and so on. Okay, so this slide's a little bit repetitive, but let's just say it again, that your method must return something, and if it doesn't return something, it still returns something, and that something is void. So if, say, we made a variation of rectangular area, which instead of returning the area, it prints out the area, and it doesn't need to return an actual number. In that case, the return type will be type void instead of an integer or something like that. Now, when we return type void, there are some consequences for the code to be aware of. So, in particular, when you run the return command, the return statement does not have anything after it if it's a void method. So, void methods must have return semicolon and not return something semicolon. Or they must have no return statement at all. So it's okay to have no return statement at all. That just means that execution returns from this method back to the main method after you hit the end of the method. But if you have a return, then it must have nothing after it if it's a void method. So if I have things like more complicated constructs inside the method, like if I have a switch statement or if I have an if statement, sometimes I can exit the method before I've reached the bottom of all the code in that method. So I can say, if area is less than 0, return. And what that's going to do is it's going to exit the method before running through the rest of the code. And sometimes that's really useful in a void method or any method, because sometimes you want the code to exit immediately. Return will always exit the method. It's sort of like a break. It's in fact more powerful than a break, because a break exits the switch or the loop that it's inside, but return leaves the method no matter what. So I could have a bunch of nested loops inside my method, but if I hit a return inside the tightest nested loop, then I still will exit the method. It doesn't interact with the loops at all. It only interacts with the methods. Okay, so here's a picture of the return semicolon that you'd have if you have a void method. If the method is not void, you cannot use return semicolon because you can't attempt to return no value if you've promised to return a value. So if I want to return some sort of value, then I would say return and the value after it. That can be an expression, so that doesn't have to just be a number or a variable. That could be, a plus b or something like that. Again, it must be followed by a semicolon. Or you can return a literal, so you can return like a number like 8 or 5, but you still need to return a type that is the same as or implicitly cast to the return type. So if I write code that attempts to return a type that it does not implicitly cast to the return type, the declared return type, then, so for example, this Boolean does not cast to double. So if I do that, then this will result in a compiler error and the code not running. Okay, so very quickly, we can have multiple return statements. If I have if, else, or switches, I can have multiple returns. And another important thing is to know is that all methods don't have to take input. You can have, many of you have already used system.out.println without giving any strings, just to generate a new line. But void works also. And I've talked about it in this casting.